This new course is going to be called Discrete Mathematics with Mathematical Modeling, and I want to explain to you a little bit about what that means and what's in the course. First, what is discrete math? Well, most of the math that you look at in, say, algebra is continuous. You can draw graphs without lifting your pen from the paper. Discrete math, instead of being continuous and smooth, you have discrete points like this. Each point is distinct, and in discrete mathematics we're always talking about distinct things, be they integers, points, people. Anything that's not continuous can be thought of as discrete. So the area of discrete math is very broad, which allows us to investigate a lot of things and still call it discrete math. Now, what about the mathematical modeling part of this? Well, we're going to use mathematical modeling to help us solve and look at solutions to problems that are real and that involve discrete mathematics. Here's an example. This is an Excel spreadsheet, and what I've done is I've written a little program using the spreadsheet and using the language hidden behind it, which is called Visual Basic for Applications, to simulate an epidemic. And we've got 400 critters here, and you can see we can't see any of them because none of them are infected. And we'll start out by infecting a few of these people, 4 of them. And then what we'll do is step at a time, a day at a time if you will, we'll see how the epidemic spreads. So we hit this button and we go one step, and now 8 people have it because each of the 4 people bumped into somebody else. And now 16. And it looks like it's doubling every time, 32. But you'll notice after 4 days there are 58, not 64, because some of these guys bumped into people who are already infected. So the infection rate is going to go fast, doubling for a while. But after a while, so many people have the disease that fewer and fewer people get it, until finally, in this model, because nobody gets well and everybody's always infectious in this model, everybody has the disease, and it took 15 steps. This was a random process, fairly easy simulation to do, and it gives us a pretty good feel for what happens in an epidemic. Notice we're learning to use an Excel spreadsheet, which is an important part of this course. We're going to do some real math, although it's not going to be a lot of algebra. There won't be a lot of x's and y's. And our real math will often be used to simulate real things. Another piece of software we're going to be using is systems dynamics software. And system dynamics is a fancy name for a modeling thing in which we treat every quantity as like a container. Like here we have containers for sheep and wolves. And as these things change, they change by inputs and outputs through valves, and the valves are controlled by various parameters. For instance, in this case, if you got a lot of sheep around, the wolves are going to do well, and the wolf valve opens up and lets more wolves in. But if you run out of sheep, you open that valve a little less, and the valve on the other side where wolves come out and die gets opened bigger. So we can look at the interaction between wolves and sheep over years, and notice there's very little math involved here. Basically what you have to do is know the important things and connect them together. And here's what that model looks like when we run it. And as you can see over time, the sheep are red and the wolves are blue. We get oscillation because if you get a lot of sheep, the wolves die off. You get a lot more wolves, then the sheep start dying off, so the wolves start dying off, and we'll get a cyclic pattern to this. So we'll be looking at models like this. This software we're using here is called NetLogo, and like all the software we're going to use in this course, it's free to use and to keep, which is very important, I think. If you're going to learn something in the course, I'd like you to be able to take it elsewhere and do more with it. And we're going to be doing some flashy and fun stuff, but we'll also be doing some old-fashioned math. For instance, here's a little Excel file in which we implement an algorithm. Algorithm is a step-by-step method of doing something that finds the greatest common divisor of 2 numbers. Like here we start with the number 30 and 12, and when we calculate it tells us the greatest common divisor is 6. Of course, the interesting thing about that is most of the time when we want to do this, we've got small numbers and we can figure that out almost in our head. But in realistic situations, frequently in real-world problems, we've got big numbers that we've got to find this for, and the calculations get very tedious. So we'll learn how to do these calculations step by step by hand, but then we'll also learn how to program the computer to actually do this with big numbers so we don't have to do all the work. For instance, right here, we're trying to find the greatest common divisor of 3,924 and 1,092, which I wouldn't like to do by hand, but you hit a button and it tells us that it's 12. That's a useful thing for some people, and even if you never find it useful in real life, the skills that you will learn in working with Excel spreadsheet and the language hidden behind it, Visual Basic, could be really valuable skills no matter what you do out in the community after you've gotten out of college. So we're preparing you for the future when we're teaching this course. Plus, we hope to have a little bit of fun. A major theme of this course is going to be something called iteration, which simply put means doing the same thing over and over again. And some of this stuff is useless, and sometimes it appears useless and actually useful. But it's a lot of fun, and it produces some really pretty and surprising pictures. For example, here's something called string rewriting, in which we take a line, and we don't do any math in this at all. There are no numbers. I guess you could call it math, but there are no numbers. We take a line, and we take a little v out of the line. And now we have 1, 2, 3, 4 different lines, and we take a little v out of each of those lines, like so. And then we take a little v out of each of those lines. Well, I think you can see what's happening, but let's expand this a little bit. Yeah, let's take 3 lines and do the same thing. And as we go along, you can see that this turns into a nice snowflake-looking figure. And it's really interesting because the perimeter of this thing gets bigger and bigger and bigger, so it grows approaching infinity. But the area inside approaches some finite number. So there we have something with a fence that has an infinite length enclosing an area that is finite, which is kind of cool. And some of you may recognize that this is an example of a fractal. And we'll be looking at this string rewriting because it's a really good way to look at problem solving. And really, that's what this course is all about. It's all about problem solving. And we hope that some of the skills you would learn in this course would generalize to things beyond mathematics. One of my favorite things, and I used to do this in Algebra 2 class, is to start with this and show how it turns into this. And this is something called the Mandelbrot set, and all it is it's iterating on that function we were just looking at, which is y equals x squared plus a constant, and it produces some of the most incredibly beautiful stuff in the realm of math and science, and we'll actually see how you can develop this and get to this point. Perhaps my favorite thing in the course. But most of the course is going to be duller than that. This will be the most exciting thing we do, I think. But the whole idea is to make you think about math problems, to make you come up with your own solutions to problems, to get you to learn how to explain your solutions so that somebody else can understand them. And I think this is what a lot of real math is about. And a bonus that's going to come out of this, a very important bonus, is you're going to be able to use spreadsheets much better than just about anybody else that you know. You're also going to learn to use some other math software. You'll learn a little programming. It won't turn you into a programmer, but it will be a skill that you might find useful later on, even if you never become a math or a science weenie. So that's an overview of the course. I hope you give it some consideration. Again, it's a one-semester course, first semester. The prerequisite is Algebra 1. If you've completed Algebra 1 and you're a good math student, you could easily do very well in this course. If you're a junior or a senior and have completed Algebra 2 and Geometry, it gives you a little better math background. A person who doesn't have a whole lot of real strong math skills still might do very, very well in this course with the background and maturity that a junior or senior would have. So I hope you give it some consideration. Remember now, we're not going to have a lot of tests in this course, but we will have a lot of projects. So if you're lazy, don't take this course, because you'll have projects due every week or two, sometimes having to work with someone else. So if you don't work well with others, this might not be a good course to take either. It's not a course that you'll be able to get by doing nothing just because you're good in math. The people who do well in this course are the people who are going to take it serious, get enthusiastic about it, and work hard. There won't be an exam. There will be a major final project, though. Thank you for listening, and I hope you have a great day and give some consideration to taking this course.